Welcome everyone. For today's prep, we're going to continue on with polar coordinates, and I want to start by looking at some important angles that are going to help us when we're looking into and investigating this new coordinate system. So we're going to start by looking at the important angles that sit in the first quadrant. So if we kind of go back to thinking in terms of rectangular coordinates, we've got our positive x-axis, we've got our positive y-axis, and this section of the plane we call the first quadrant. This section over here is the second quadrant, third quadrant, and then fourth quadrant. So let's just get those different quadrants labeled. So we've got our first quadrant, our second quadrant, our third, and ultimately our fourth. So we're just thinking in terms of our different quadrants. And to get us started, we're going to be looking at these angles. And all of these important angles are going to be sitting in the first quadrant here. So what is theta 0? Well, theta 0 corresponds to the positive x-axis. Pi over 6 comes next, then pi over 4, then pi over 3, and then pi over 2 corresponds to the positive y-axis. All right, so let's go through, and we want to identify what are the radians for all these other important angles that we're going to see. Important angles that sit in the second quadrant, the third quadrant, and the fourth quadrant. What are these other radians? So let's start with multiples of pi over 2. So let's write out all of our multiples of pi over 2. So 0 kind of starts us off. That's a perfectly valid multiple of pi over 2. Then we can have one copy of pi over 2. Then we can have 2 copies of pi over 2. We can have 3 copies of pi over 2. And 4 copies of pi over 2. And this does keep going, but we're going to stop there. All right, so we've got 0 already listed. We've got pi over 2 already listed. Now 2 pi over 2, that simplifies to just pi. So let's start by looking at, so when we're talking about these angles, you almost want to imagine slicing up our plane here, or our grid, into wedges. So we've got this pi over 2 wedge, which starts at our x-axis and goes up to that radian pi over 2. Now, if we wanted to figure out where the next wedge would sit, we just imagine taking this whole thing and rotating it counterclockwise. And what you can see is that if we rotate this wedge counterclockwise until it kind of fits into place, well, we're going to end up with this as our next wedge. So that means kind of the end of that is going to be our next multiple of pi over 2. So in this case, that's where pi is going to be. So 2 pi over 2 simplifies to just pi. And this gives us a way to kind of think about what we're really doing here. So if we remember back, pi represents, if we think of it in terms of degrees, pi represents 180 degrees. So what we're doing here is we're taking half of a circle, and by dividing that into 2, we're dividing that into 2 equal wedges. So we've got one wedge here, one wedge here. So that's what pi over 2 is doing. And then if we keep going, we've got another wedge here. So this would be our 3 pi over 2 wedge. And then we've got another wedge here. So that means this edge also would be a multiple of pi over 2. And we can think of that in terms of 4 pi over 2, or simplified to just 2 pi. All right. So let's try this now with pi over 3. So let's think about all the different multiples of pi over 3. All right, so let me erase this. And again, 0 we're going to start with. Then we've got pi over 3. Then we could have 2 copies of pi over 3, 3 copies of pi over 3, 4 copies, 5 copies, and then 6 copies. And we're going to stop there because we'll see this is equivalent to 4 pi over 2, or just 2 pi. So we eventually kind of start overlapping. All right, so if we look at our pi over 3 wedge, our first pi over 3 wedge is right here. And what we're going to do is imagine taking this wedge and just rotating it counterclockwise, and we're going to wait for it to kind of click into place. So once there's enough space for this whole wedge to kind of fit in. And as this goes around, as we're rotating, the edge will end up over here. So this edge means this is now our second copy of pi over 3. And if we do it again, take this wedge, rotate it now counterclockwise, and that would fit in right here. And pi is the same thing as 3 pi over 3. All right, so what we see here, because we're looking at the multiples of pi over 3, really what we're doing is we're dividing the half circle, represented by pi, into 3 equal pieces. So we've got our first equal piece, our second equal piece, and our third equal piece. So we divided the half circle up into 3 equal pieces. So you could play the same game with pi over 4 and pi over 6. So we won't go through all those. But for pi over 4, if we go around, we've got the 1 wedge for pi over 4, 2 wedges for pi over 4, and then 3 wedges for pi over 4. So that means this angle would be 3 pi over 4. Then our 4th wedge is we're back pi. Our 5th wedge would be 5 pi over 4, which would be here. And then we've got our 6th wedge, and then our 7th wedge, so 7 pi over 4. And then by our 8th wedge, we're back to 0, or we're at 2 pi. Now what about pi over 6? Well, we've got 1 copy of pi over 6, 2 copies of pi over 6, 3 copies, 4 copies, 5 copies. So this would be 5 pi over 6. Then we've got 6 copies, which we're back to pi. Then 7 copies, so 7 pi over 6. 8 copies. 9. Oh. No, I forgot the 8 copy is actually going to be another multiple of pi over 3. So I think we forgot to do those. Well, let's keep going with the pi over 6. So we've got 7 copies, 8 copies. So 8 pi over 6. But that just simplifies. So we can factor out a 2. So this is just going to be 4 pi over 3. If we simplify that. So that's 8 copies of pi over 6. Then 9 copies. Now 10 copies. But again, same thing, we could factor out a 2. So that's 10 copies of pi over 6, or 5 copies of pi over 3. And then finally 11 copies of pi over 6. And then when we're at 12 copies of pi over 6, we're at 2 pi. So you don't necessarily have to have all of these memorized. You want to have the first quadrant memorized, and then from there you can just kind of imagine rotating counterclockwise to fill in the remainder of these, kind of like what we did. All right, so once we know where each of these different angles is, we can then plot points. So let's try a couple examples. So let's look at the point 2 comma 5 pi over 6. Now this is represented in polar coordinates. So what this is telling us, this is not Cartesian coordinates anymore. What this is telling us is that our r value is 2 and the theta value is 5 pi over 6. So when we do this, you usually want to start with the theta value. So we're going to start by finding where is the angle 5 pi over 6. So if we remember, pi over 6 is kind of this shallow angle in the first quadrant. And then we're just going to imagine rotating this wedge 5 times counterclockwise. Because what do we have? We've got 5 copies of this angle pi over 6. So we've got our first copy, our second copy, our third copy, our fourth copy, and then our fifth copy. So this is the angle 5 pi over 6. So that's the angle we want to look at. Now to plot the point, we found our angle, so now the r value tells us how far to move away from the origin. So we've got our origin here at the middle. We know we're looking on this ray, and we're going to count out 2 units. So we've got 1 unit, 2 unit. So there's our point. 2 comma 5 pi over 6. Now let's try the next one. 3 comma 5 pi over 2. So again, if we think about what do each of these coordinates mean, well, the r value here is 3, and the theta value here is 5 times pi over 2. So when you're doing this, you want to look for that kind of the main angle part, that important angle part, and then any other constant, you can think of it as like a multiple of that. So we want to do 5 copies of pi over 2. All right, so pi over 2 starts us at the positive y-axis. So again, we've got the wedge, this wedge here. So if we imagine we've got 1 copy, now rotate that counterclockwise. So that'll give us our second copy. Then rotate that counterclockwise again until it fits. We've got our third copy, then our fourth copy. And then, so we've got 1, 2, 3, 4 copies of pi over 2, but we want 5 copies, so we're going back. And this angle, pi over 2, is the same thing as 5 pi over 2. So the angle pi over 2 and the angle 5 pi over 2 are describing the same ray directed out of the origin there. All right, so once we've located that ray, we just have to count out the appropriate number of units. So we want to go 3 units away from the origin. So we're going to go 1, 2, 3. And there's our point. So this is the point 3 comma 5 pi over 2. All right. So we are going to practice a few more of these examples, just kind of getting the hang of plotting different points in polar coordinates. But it really comes down to just knowing these important angles and being able to identify where they sit on this kind of circular diagram. All right, so work on trying to have these memorized, at least the ones in the first quadrant. And we'll see you in class. Bye-bye.